Okay, hello everyone, welcome back. This is Professor Lloyd and this video is for chapter 13, Supply Chain Logistic Networks. So in this chapter, we will continue to talk about supply chain. And more specifically, in this specific chapter, we will focus on talking about how we can properly locate our facility, our factory, our warehouse, given certain type of supply chain information. All right, now let's start. So as you can clearly see here, I list some learning objectives for this specific chapter. Before we even jump into those quantitative or qualitative methods, we need to first understand what are the key factors underneath this through process, all right, that can greatly affect the location choices. So that would be the first thing that we need to clarify. After we got to get a solid understanding about that, then we start to jump into those different quantitative methods that can help us to basically get the most appropriate location. The first specific quantitative method that we will introduce is called low distance method. All right. If we use this specific method, basically we're trying to minimizing the transportation cost through supply chain. Okay, that's the core idea. So based on that idea, we will further apply a very important physical idea called center of gravity that can help us to basically figure out what would be the most appropriate location for this whole supply chain after we incorporate the customer, after we incorporate supplier, those different supply chain information. All right, so this will be the first quantitative methods that we will detailedly talk about in this specific chapter. The second specific method is called break-even analysis. Actually, we already talked about break-even analysis before. Here, we also use break-even analysis to help us figure out what would be the most appropriate location among different alternatives. Suppose we already get some financial data about different alternative location. Okay, so that will be the second method that we introduce in this specific chapter. All right, so besides that, we will also talk about what would be the role of geographical information system when we make, location decision. All right, so this whole process, how it will actually affect our final location decision. Okay, and also we will link the supply chain logistic network idea with the inventory placement. All right, so basically here we will introduce two different general inventory placement strategy. Okay, one is called centralized placement of inventory. Another one is called forward placement of inventories. Okay, we will detailedly talk about basically in what circumstance centralized place of inventory is better, in what other circumstance forward placement of inventory is better. All right, we will get a solid understanding about how the supply chain logistics network will impact the inventory placement. All right, so in general, basically here I provide roadmap of different topics that we will cover within this specific chapter. All right, now let's start. So here you can clearly see that we start from the definition of facility location. Okay, the definition of facility location itself is very straightforward. Basically, it represents a process of determining the geographic size for firm's operations. Okay, no matter we're trying to build a factory, a warehouse, a retail store, or a distribution center, basically, as long as we try to determine the geographic size for different purposes in order to maintain the firm's operations, this process can be viewed as a facility location decision process. All right, and it's not that hard to basically find a specific place for this specific company's operation. The most important thing here basically is to use the supply chain information to figure out the most appropriate and the most efficient site for that specific purpose. All right, that's what we are talking about in this specific chapter. Before we even jump into the quantitative methods, I would like to point out a few different key factors that may significantly affect the location decision process. All right, so all of those factors, first of all, has to be very sensitive to location. All right, that should be very straightforward. Secondly, all those factors have a significant impact on company's ability to meet its goals. So basically, all those factors has to be very closely connected with their competitive strategy through this whole process. All right, now let's look at all those different factors. Now, let's first look at some dominant factors in manufacturing type of the company. All right, as I clearly list here, one of the most important key factor in manufacturing type of the company will be the labor climate. Currently, more and more globalized market, more and more manufacturing type of the company they're willing to set their specific site or factory or warehouse in a region or in a country that actually has a lower labor cost when they can maintain the overall quality. All right, such that it actually can help to minimize their operating expense through this whole process. So that's why here, this will be one of the most important key factor in manufacturing type of the company's location decision process. All right. So another very important factor would be proximity to markets. This is actually very crucial, especially for those products that really need customers test before they purchase it. Okay. So for those specific type of the product, customer has to first look at those products before they decide whether they would like to purchase it or not. So for this certain products, it's actually very beneficial if we can set our, for example, retail store near to the customer population, such that if customer decide to look at it or test it or experience it, they can easily come to the retail store before they purchase. All right. So that's why proximity to markets is also quite important. Another very important factor would be impact on environment. We know that for a specific type of the product, actually it can lead to some air pollution or it can actually impact the surrounding community, right? So no matter the city or state or in the federal law may set some restriction towards that. So that's why here, when the manufacturing type of the product, especially for those specific products, they have to think about those restrictions or limitations when they set their site in certain area. Okay. Or besides that, the quality of life, this is also related, right? The proximity to suppliers and resources, this is also important, especially for some products that really depend on the suppliers transportation, right? So if the supply transportation cost actually takes a huge percentage on the total expense, then it's better to basically set your factory near to supplier, right? Such that it can actually save a huge amount of the operating expense through this whole process. This is also quite important. Or for certain type of the products, it really needs, your factory to coordinate well with the parent company. And then in those cases, maybe it's better to locate your specific factory near to the parent company, near to the headquarters. That's actually quite important. All right. And through this whole process, the utility, the taxes, the real estate cost also plays a very important role through the whole process. All right. Now, let's also look at some dominant factors in service type of the companies. So it's a little bit different from the manufacturing type of the company because especially for service type of the company, it has a higher connection with the customers. So that's why you can see that proximity to customers becomes really crucial because every service type of the company really wants to improve their interaction with their customer in order to improve their overall satisfaction level. All right. Another very important factor can be location of competitors. All right. We all know that if we set our site near to our competitor, it has some advantage, but it also has some disadvantage. All right. So if we set our site near to a customer, and if we do have some competitive priority or competitive advantage compared to our competitor, then probably we can take some of their customer to our site. All right. However, through the severe competition between you and your competitor, it may also damage your potential revenue in this whole process. So that's why in some circumstance, service company is more willing to basically set their location away from their competitor such that they can actually attract a new group of the customer in order to finally boost their overall sales, boost their overall revenue through this whole process. All right. Now, after we get a solid understanding about those key factors within no matter manufacturing or service type of the company, when they basically make their location decision through this whole process, all right, now we will start to talk about a few different quantitative methods that are frequently used within supply chain logistic network type of the questions. All right, the first type of the method is called load distance method. In this specific method, we're trying to use this specific technique to minimize the overall transportation distance or correspondingly the overall transportation cost. All right, so let me give you a quick example. Suppose we're a company, and right now we are trying to basically set our factory in Texas, and our customer populations are mainly from 3 cities. All right, Fort Worth, Dallas, and also Austin. Okay, what would be the most appropriate location I should locate my factory at? Okay, that would be a very important question for our company. All right. So we know that we have some customer from Fort Worth, we have some customer from Dallas, we have some customer from Austin. Okay. So according to transportation distance and also according to the specific customer amount, okay, how we basically set our factory, that can actually help us to minimize the overall transportation distance among 3 cities. Okay. So that will be the main question that we would like to use low distance method to help us figure it out. All right. Since this is related to distance, here we provide 2 specific distance measurements to help us basically measure the overall distance. We call it Euclidean distance or rectilinear distance. Okay. What is the key difference here between Euclidean distance and the rectilinear distance? Very simple. The Euclidean distance basically is the straight line distance, or we call it shortest passable path between 2 points. Okay, suppose here you see x1, x2 are 2 different places. Okay, the Euclidean distance basically is the straight line distance between these 2 points. All right, the rectilinear distance basically is the distance between 2 points with a series of 90-degree turns. Okay, so that's why you see basically all of distance starting from x1, right? We move here horizontally and then vertically move back to x2. The overall distance here basically is called rectilinear distance. Okay, so basically here, if we are within a coordination, every single place can be viewed as a pair of x and y value within that coordination. How we get the corresponding Euclidean distance and also rectilinear distance? Very simple. The equation I already show here. Okay, so basically, since no matter x1, x2, okay, both points can be viewed as a pair of x and y value, right? So that's why here you can first calculate the difference of x value between these 2 points, okay? And also you can calculate the difference of y value for these 2 points, all right? And then separately you take the square and then sum it up, okay? But finally, don't forget you take the square root. That will provide you the distance between x1, x2. Which is the Euclidean distance shown here, all right? And on the other hand, if we want to calculate the rectilinear distance, this is also very simple, okay? Since here, still x1, x2, right? Every one specific place can be viewed as a pair of x and y value within that coordination, right? So you still calculate the difference of x value and also calculate the difference of y value, okay? And then you calculate the corresponding absolute value and then sum it up in order to get the corresponding rectilinear distance. Okay. Here, basically, in some information context, Euclidean distance is more appropriate. In some other information context, rectilinear distance is more appropriate. So it actually depends on the information context itself to decide whether we should use the Euclidean distance or rectilinear distance. But normally in the example, they will directly tell you that which distance measurement is more appropriate within that specific application. Here, I would like to emphasize that no matter you use Euclidean distance or rectilinear distance, what it can provide you is the unit distance between your location and, let's say, one specific city. Okay. However, in order to get the load distance, you also need to further incorporate the number of the customers within that specific city. Okay, for instance, if you have 5,000 customers within Fort Worth area, and further, if every customer order one specific product, all right, so in order to fulfill all of the customer order from Fort Worth area, you need to basically deliver 5,000 times. All right, so the overall load distance is basically the unit distance between your location and Fort Worth times 5,000. All right, suppose you have another 3,000 customer within Dallas area, you have another, let's say, even 10,000 customer within Austin area, you basically repeat this whole process, okay, and do the corresponding calculation for load distance before you sum it up to get the overall score. This is basically the underlying reasoning of this, you see, LD score showing here, right? You basically calculate your load distance for every city, and then you sum it up to get the overall load traveling distance, okay? Now, after we get a solid understanding of the load distance methods, we can start to apply the key idea showing here, all right, to basically find out the most appropriate location that can minimize the overall transportation distance. We call it center of gravity method because this whole searching process is a little bit like searching the center of gravity in physics, all right? Now, here I would like to use one specific example to illustrate the core idea of center of gravity method. All right, let's start. So here I provide you example 1, okay, which is a very standard example that can basically use the corresponding information context to get the corresponding center of gravity that can minimize the overall transportation distance. All right, let's start. So suppose you are a supplier to the electric utility industry, which produce power generators. And we know the transportation costs are high, and that's why we're trying to, constrain our overall transportation costs into a proper level. One market area includes the lower part of the Great Lakes region and the upper portion of southeastern region. Okay, and more than 600,000 tons are to be shipped to 8 major customer locations, as shown below. So the table already basically summarized some of the corresponding information for you, especially related to the customer population within different locations. All right, for example, in the first one, 3 Rivers in Michigan, right? The customer population here show you basically you need 5,000 tons to be shipped. All right, and the corresponding X and Y coordinates values for this specific customer location is already showing within the last column. All right, now basically given all of those customer location and the corresponding population specific information, how we can properly find the most appropriate location for our own factory, that is actually quite important to figure it out. Now let's continue. All right, so before we even start to use the specific center of gravity method, okay, to basically figure out the the best X and Y value for our factory location within that coordination, okay? I would like to first let you see what it looks like, okay, within the X and Y coordination. You can clearly see that here, every dot C1, C2, C3 until C8 is basically representing every customer population location, all right? We want to find one specific location point for our factory, which can basically minimize the overall transportation cost, transportation distance, okay, but also fulfill all of the customer orders from all different, specific customer location. Okay, that's our target. Now, let's start to look at the technical part. All right. Now, first of all, since we're trying to find this specific center of gravity, and since this center of gravity is also basically a point which is basically represented by the corresponding X and Y value, right? How we get the corresponding best X and Y value? Very simple. As you can see here, the equation to get the corresponding X star, all right, is basically the summation of II XI divided by summation II, all right? How to calculate this? Very simple, okay? Here, you already see that basically the customer population within every specific location is already showing in the second column, right? And the corresponding XY coordinates for the corresponding customer location is already showing within the last column. How you basically calculate the X star? We start from the numerator, okay? How we calculate numerator? Very simple, okay? You directly, okay, calculate the customer population within that specific location times the corresponding customer location X value. So that's why here, if we view it as in 1,000, then this should be 5, right? You use 5 times the corresponding 7 to get the first element. All right. You repeat this process for every single row. You will get the corresponding value, which is exactly showing here. Okay. So that's why after you get all of the corresponding elements, you simply just sum it up to get the numerator value, which is 7,504. Okay. And then how we get the corresponding denominator? Very simple, right? Still, basically here, since the denominator is actually represented by the summation of II, how we do that? Very simple. You simply add them up for the second column, which basically represents what is the total customer population. Okay, what is the total customer population? All right, so here, since this is in thousand, that's why you see finally the result will be 607. Okay, you use what you get here with the numerator, divide by 607 to get the corresponding X star value. This X star value basically is the X value of the center of gravity. Okay, then you can already imagine how we get the corresponding Y star for the center of gravity. Still the same thing. Basically here, all right, you use the customer population for every single location times the corresponding Y value for that location. Okay, and then you repeat this process for every single customer location. Okay, that's how you get the, you see, the numerator of, the equation for finding the Y star. Okay, so that's why here you get 5,572, which is basically the numerator here. Okay, the denominator is still the same because basically you do not actually change your customer population in total, right? So that's why here it's still represented by the summation of II. That's why it's still 607, which is exactly the same denominator as we show here to find the X star, right? So here the denominator is still the same. And after you do this, you will find out what is the corresponding Y star. Okay, so that's why here we see the X star is 12.4, the Y star is 9.2. Okay, don't forget this X star and Y star basically represents the specific point within X and Y coordination within that specific plot that I just showed you guys, right? You can see that when X star is around 12.4, which is shown here, right? When Y star is around basically 9.2, you see, that's why you see the red dot show here represents center of gravity, which indicates that without considering other factors, if we only look at basically the transportation distance, this specific point can provide you the overall, minimize the transportation distance, okay, by, basically delivering all of the customer orders from 8 different customer locations. Okay, so this will be the whole process of, applying the low distance method to basically find the most appropriate location site that can minimize the transportation distance in this whole process. All right.